First one that I'll talk through here looks like the following. All right, if you're given an expression to factor, and it's a quadratic expression, and the leading coefficient is something other than a 1, one way that you can approach this is to use trial and error. What trial and error does is it's based on the idea of when you take binomial factors and you expand them or multiply them, you FOIL, right? You take the product of the first, the product of the outer, the product of the inner, and the product of the last, and you add all those together. Okay, but that yields a pattern. So this first term of your final answer has to be the product of your first terms of the binomial factors. So if we look at our two binomial factors, the first two terms here and here have to have a product of 2x squared. Okay? For this particular case, what's the only two numbers that you can multiply together to equal 2x squared? 2x and x, that's it, right? Assuming each of the binomial factors has to have an x in it. Okay, so by doing that, you know that these have to be your first terms of your factors. And now, when we look at the last term of your factors here, we see that the last terms have to have a product that's equal to 7. Okay, so the product is positive, which means both signs have to be the same. They're either both positive or both negative. That and the outer and inner sum of the products has to be a positive number. All right, so if you know that the outer and inner sum has to be positive 9x, and the product is positive 7, that means the signs are the same. Since the sum is positive, we know that each of these signs has to be a plus. And then what are the only two numbers whose factor or that can multiply together to equal 7? 1 and 7 or 7 and 1. That's the only combination. So using trial and error here, we only need to test two variations of this and in order to find our solution. So let's test the first one. When we test it, we're testing using the FOIL method. Well, we already have our first and our last. All we need to worry about is this, the outer plus the inner terms. So what's 2x times 7? 14x, and then 1 times x plus x. Does this equal 9x? No, so we can eliminate that one. And let's test the next outer plus inner. So here's our outer. 2x times 1 is 2x. Here's our inner. 7 times x is 7x. Does that equal 9x? Yeah. So that is our solution. We have our factors. 2x plus 7 and x plus 1. Do you guys recall that? Does that look somewhat familiar to you guys? Okay, try this one on your own, please. And you know the product of the first terms has to be 3x squared, so what's the only possibilities for that? 3x and x. The product of your last terms has to be a negative 2, so what are your possibilities for that? Negative 2, positive 1, positive 2, negative 1, negative 1, positive 2, positive 1, negative 2. So here you have 4 different combinations that you have to test, right? And so if you use trial and error to test these, take our outer plus inner product. So here's outer plus inner. So we have a 3x and a minus 2x. Does that net you a total of negative 1x? No, so that's not it. Go to the next one. Our outer is 3x times a negative 1, which is negative 3x. Our inner 2x times x is plus 2x. Do we get an overall sum of minus 1x? Yeah, so there's your factors. Those ones work. And so your answer is 3x plus 2 and x minus 1. Okay, so you see here, I mean, in both of these, here I only had to test 2 of them, and I got it on my second one. Here I'd only have to test a total of 4. I got it on my second one. So it wound up being decent as far as the efficiency goes. Okay, reverse foiling or trial and error, it works well when your leading coefficient and your constant are prime numbers. And in fact, I'll show you a more efficient way to approach this tomorrow. However, if your leading coefficient and constant are prime numbers, I'd still encourage you to reverse FOIL. Use trial and error. It's very quick in that form. Okay. All right, so let's take a look at the case where this method is not all that efficient. Okay, I want you to try this on your own. Or not necessarily all that efficient. So 4x squared plus 11x plus 6. See if you can factor that expression, please. Right, if you follow the same process, what reverse foiling means. So our first terms of these binomial factors have to have a product of 4x squared. So the 2 different possibilities, 4x and x. But we could also have had a 2x and a 2x, right? So this sets up two completely different possible groups here. Okay, and now we can look at our last term. Our last term has to have a product of positive 6. So the fact that it's a positive product means the signs are the same. The fact that the outer plus inner sum is positive means those signs have to be plus. So we know that these are all going to be plus, so that at least cuts in half all the potential values we need to test. And now let's just find all the different factors that yield 6. So 1 and 6, 6 and 1, 2 and 3, 3 and 2. So all of those different possibilities need to be tested for both cases. So 1 and 6, 6 and 1, again for this last term, 2 and 3, 3 and 2. So now we have 8 that we need to test for this. So you can see how, depending on how many different factors your leading coefficient and constant have, it could create a lot of work for you. And now, if you are somebody who feels more comfortable using trial and error than what I'm going to show you tomorrow, you can still eliminate or reduce the number that you need to test here. And so let me kind of talk through how you can eliminate these. So if you look through these combinations, before you even start testing them, one of the things I can look at here is this second combination, 4x plus 6. Well, what do you notice about those two terms? Are there any common factors between those two? Yeah, they have a common factor of a 2, right? So what that means is if this was the solution, then you should be able to take a factor of 2 out of this original term, or this original expression. Can you take a 2 out of each of these terms here? No. So we know that this one is not correct. Okay, what about 4x plus 2? Same thing, right? So we can eliminate this combination. Okay, let's go to this next set. 2x plus 6, that can be eliminated. 2x plus 6 here can be eliminated. 2x plus 2 can be eliminated. 2x plus 2 here can be eliminated. So we wound up eliminating all 4 of these, right, just by understanding like the way that factoring works. And so now we just have 2 to test. Okay, so we took this from what looked like a daunting task of testing 8 different possibilities to using properties to eliminate the unrealistic ones. And so now just if we test the outer and inner. So here's our outer 4x times 6 is 24x plus our inner 1x. Does that equal 11x? No, so we can eliminate that. Let's test our outer here. 4x times 2 is 8x plus 3 times x is 3x. Does that equal positive 11x? Yeah. So we wind up with our factors. 4x plus 3 and x plus 2.